This is the video lesson for 2.7, combining functions, and in a little bit we'll do 2.8, inverse functions. Okay, so let's just start out with something we kind of know how to do, but take it a little bit further. So we're given two functions, we have a rational and we have a square root, and we're going to do these operations, and it is exactly what you'd think it would be. Now when this says domain will be the intersection of the domains of f and g, it may be that this little statement doesn't really matter, because just by looking at our answer we'll be able to identify the correct domain. But let's go ahead and do example 1 and I'll explain more what this is, or example A. So for f plus g we would just add 1 over x minus 2, and to that I would add g of x, which is square root of x. Now, there's really no way to combine this. This is your function. So when I say the domain is the intersection, it's obvious here. You just look at each piece. We have x greater than 0, but we also have to skip 2. So then our domain is going to be all the numbers that are greater than 0, but we're skipping 2. So I got to skip over 2 and go straight to 2 to infinity. Okay. Let's look at this next one. It would be almost identical, okay, but I would have 1 minus x minus 2, or 1 over x minus 2, then minus square root of x. And then this would have the same domain, okay? F times g, let's think about this. If we're multiplying, you'd multiply top to top, bottom to bottom. So then you would have the square root of x over the x minus 2. So just looking at this again, you know that you have to have values that are greater than 0, and then you also have to have x not be 2. Okay, so the domain has been the same all the way through. For all three of these, this was your domain. And just to be clear here, this is a bracket. Okay, now looking at D, it's a little bit different. Okay, so I'm going to switch up the color just to really emphasize this. We have a fraction divided by square root of x, okay? So this would be like multiplying by the reciprocal of square root of x. So here our answer is 1 over square root of x times x minus 2. Alright, so how is this actually changing my domain? There's one number that I now cannot include that I was including before, and it's that 0 right there. On A, B, and C, x could be 0, no problem. On D, we've moved this term into the denominator, so x cannot be 0. That cannot be a number in my domain, so you need a parenthesis there. Okay, and I'm going to really make sure this is curved. It's kind of hard to tell sometimes with this. This is a parenthesis. 0 to 2, still skipping 2. It's basically the same, but we just cannot include 0. Okay, so then you get into where you have this number here. Now, anytime you have a number out in parentheses, it does not mean multiply, it means sub in for x. So this kind of relates to A. So we're going to plug 4 in to our expression for A. So we would have 1 over 4 minus 2, and then plus root 4. And this number is in our domain, so we're even able to do this. Any number outside of my domain, I couldn't even answer this question at all. Alright, so that's going to give me 1 over 2 plus 2. Alright, so this is 2.5, or you could write it as 5 halves. Either way. Okay, so now moving on, we have two other functions, and they're asking us to do something a little bit different. This is composition of functions. This is said f of g of x. And last year this was probably a pretty difficult concept. I think this year you'll find that it's a little bit easier. So the way we're going to start this is just going to start from the inside out. So instead of g of x, I'm going to write what g of x is equal to, x minus 3. Don't try to do this all at one time. That's how people get confused. So now I'm trying to find f of x minus 3. So instead of x squared, I'm going to have x minus 3 squared. All right, which is simplified x squared minus 6x plus 9. And if you need to write that out twice and FOIL it, be my guest. Okay, now we look at this, g of f of x. This is different. This time f of x is the input. So I'm going to put x squared right here. And so then I have, instead of x minus 3, I have x squared minus 3, and that is simplified. So notice that I got a similar type of function, but these two things were not equal to each other, and that's what's going to happen most of the time. Now, do any of you remember what happens when these two things are the same? Okay, when they are the same, that means that these two functions then are inverses. Okay, and we'll get to that in a little bit. Okay, here we have the domain of f of g of x. Remember, this is our composition function or composite function. The domain now, we have to not only consider our final product, but also what we inputted. Okay, so we have to consider both of these. Now, a lot of times it really won't matter if you forget g of x, but on the rare problem, it will matter, and if you forget that, you're going to have numbers in your domain that really shouldn't be there. Okay, so let me show you this, and this g of f, this is just another way to say g of f of x. Okay, so once I find this, I need to consider both my final product and f of x. Okay, both of those domains have to be satisfied for my final domain. All right, so g of f of x, I would start with the inside and I would write square root of x. Okay, and now what I'm going to do is I'm going to plug square root of x in for x. All right, now this is kind of strange because we're going to have a square root within a square root. All right, so I have 2 minus square root, of x, but then there's a square root over all of that too. Okay, this is, we're not going to worry about how to simplify this or what to do. There's no squaring both sides because this isn't an equation, it's just an expression, so really this is all we can do. All right, now when we're finding domain, all right, first of all, what is the domain of our input, f of x? We have to consider this. Okay, if we look at that, it's the parent function, so that's easy enough. That's, you know, we could write it as x greater than or equal to 0, or we could write it as 0 to infinity. All right, now we need to consider the domain of my final product. Okay, what is the domain of square root of 2 minus square root of x? Okay, now you can actually solve this out as an expression, or you can just think about it logically. Not everybody's good at thinking it out logically, so I'm going to show you how you would do it as an equation, well, really an inequality. You would take what's underneath the square root, you would set it greater than or equal to 0. Now this is a radical inequality, and we did this in chapter 1. Okay, so I'm going to subtract the 2 over, and I have negative root x greater than or equal to negative 2. And then I'm going to divide by negative 1, and when I do that, I have to switch that inequality. We know that. And now this is not as simple as squaring both sides. Okay, this is, we really have to think about what numbers can I square root, and then they're less than 2. So there's still a logic element to this. One thing though that you can do is you can plot these on a number line. What numbers would satisfy the equation? Okay, we know 4 would, but also negative 4 would. And think about it this way, if you were to have squared both sides, you would get 4 and negative 4 for your answers to the equation. So we have to consider both of these. Now I'm going to put closed circles around these because you would want to include both of these points. Now it's either going to be the numbers in the middle or the numbers on the outside, and what makes sense. We'll do a test point if you're still not sure. Let's test 0. 0 is true, so I shade that and don't shade the outside. You could do more test points if you wanted. So the domain of just this piece, okay, would be, it's looking like it's negative 4 to 4. Okay, but going back to, this is why we consider f of x. And even just looking at this, you can kind of figure out that my domain is not negative 4 to 4. But even just looking at this piece, I can see that I still cannot have actually in x a negative 4. Or you could look right here. It's not about memorizing what to do. It's about using your brain to figure out, you know, whenever you have to do domain, you have to use your brain. So I don't want a negative 4 there, okay? I really just want from 0, all right, to 4. that is the domain. Many different ways to do this. If you still have questions about this, please ask me in class tomorrow. Okay, number 4. Here we have another one, and this time they're giving us the end product and they're asking us for the two pieces. Now there are many different answers you could put here, so be easy on yourself. First, I'm going to look at the inside part with g of x, okay? And then I'm also going to look at the inside part of this function. All right, I'm going to let g of x be x plus 9. Then what would f of x be? The outside part, the outer function, so to speak. It would be the 4th root. Now you don't want to write 4th root of x plus 9, just of x. Now remember, you're plugging in x plus 9 in for x. You could have done this slightly different, all right? So if you came up with a different answer, it's definitely possible it could be right. All right, so let's look at the next one. Again, you want to look on the inside part, the g of x. You want to look at what's close to x. Now on this one, I'm going to go ahead and just take the whole denominator, x squared minus 8. To me, this seems like the easiest route. Then what would f of x be? It would be 5 over, not this thing, but x, because of the input. And you can easily check to see that these work just by doing f of g of x. Okay, now let's talk about inverse functions. All right, f of x has a domain A, a range B, and this right here, okay, and this is not necessarily to the power of -1. I mean, it's not that at all. It's just the notation for the inverse of x. So when you see a function with like what looks like an exponent -1, it does mean the inverse of that function. The domain and range has flipped, so the domain then would be B, and the range would be A. Now there's a lot of talk about whether the inverse is a function, or does it remain a function, or do we make it a function. This is a talk we're going to have as we do this lesson and then in class tomorrow. So it says the graph of the inverse of f is a reflection of f of x across the line. Hopefully you remember this part from last year. Y equals x. Now on y equals x, all the x values are the same as the y values. So switching x and y don't make any difference. Okay, remember back to geometry when you had to switch x and y, it was a reflection across this line. That's because switching x and y, where x and y get replaced with each other, that's what inverse function is all about. Okay, so it says if f and g are inverses of each other, then f of g of x equals x and g of f of x. So not only do these two things equal each other, they equal x. They simplify all the way down. Now sometimes that's hard to do, but if you can prove that these two things are equal to each other, then you've got two inverses on your hands. Furthermore, you should be able to prove that they equal x. Okay, so let's do an example. These are just points. Now remember, when you have a number inside the parenthesis, it's an x. When you have a number outside the parenthesis, it's a y. Same thing here. When x is 3, y is 7. These are like the points 1, 5, and the point 1, 3, and the point 8, -10. So when I'm saying the inverse of 7, we're flipping now. Now the y value, what used to be the y value, is now the x value. So what do you think this is going to equal? The only obvious answer here is 3. Okay, you're just switching x and y, and these are just points. It's not graphs, it's just points. Okay, so then what would be the inverse of 5? You have to find 5 up here, not on the inside, but as the y value. Input and output have changed, and that's going to be 1. Okay, if you get a question on this on the test, there will be no partial credit, so make sure you know how to do that. Okay, now we're going to do inverse of actual functions as equations. Okay, remember we said we're switching x and y. So right now, the f of x might as well be saying y. So the algebra involved is to switch x and y. We have x equals y to the 5th minus 3, not minus up there though, minus 3 over 2. Now the only other thing you need to do is get y by itself. Okay, so what I'm going to do is I'm going to switch, or I'm going to multiply both sides by 2. I get 2x equals y to the 5th minus 3. Okay, then I'm going to add 3 to both sides. So at this point, I'm going to move up here. I have y to the 5th equaling to 2x plus 3. And then I'm going to take the 5th root. So I have y equals the 5th root of 2x plus 3. And maybe the last thing you should do is rewrite this in function notation. the inverse of f is the fifth root of 2x plus 3. One thing you need to consider is the domain. Remember, domain and range have flipped. This is an odd degree polynomial. So if you remember an odd degree polynomial, it's going to continue to go up and right and down and left forever and ever. So you've got both a domain and range of all real numbers. So I don't have to worry about this wacky domain on this problem. On the next one, I have other issues. I know that the domain of this is not all real numbers, so we'll talk about that. Let's first just find the inverse. Okay, remember this f of x is like a y, so I'm going to change that to an x. And then I'm going to change this x to a y. We're just flipping x and y. Okay, now what would I do? I'd square both sides. So then I have x squared equals y minus 2. So then moving up here, I can see easily that y is equal to x squared plus 2. And more correctly, I would say that the inverse of x, the inverse function of x, is equal to x squared plus 2. And this is my final answer. Now, I need to consider a domain problem here. All right, let me draw a quick graph, and this may be an easier way to explain it. My original problem was the square root function moved to the right 2. It looks like this. My end result is a parabola moved up 2. Okay, so looks like this. It's just a rough sketch. Now remember what I said about the graph is a reflection across the line y equals x. Now would you say that these two graphs are true reflections? No. It's only, really, I should only take half of this parabola. Which half of this parabola should I take? This half right here. You can see that this really is the true reflection. Okay, so what's the domain on this parabola? Well, it's for all the x's greater than 0. So I really need to tag on 4 x's that are greater than or equal to 0, or you could put this in interval notation, but really my inverse has to only be for x is greater than or equal to 0 for it to be a true inverse to the square root graph. This is not a step we required of you last year, but it is what we require this year. Okay, last thing is this idea of something that's one-to-one. And this is an important phrase. It's good to note this to memory, but also hopefully you'll really understand what it is. It says a graph is said to be one-to-one if there are no repeated x values, meaning it's a function, it passes the vertical line test, and no repeated y values, it passes the horizontal line test. Basically, if f of x is 1-to-1, then f of x is a function, which we knew that just by it being said f of x, but then also its inverse is a function. Okay, so look at this right over here. And before I answer A, I'm really going to answer B and C. Is this a function? Yes. This is a cubic. It's been shifted and stretched and all that, but it is a cubic. It could be a higher order polynomial, but I know it has to be an odd polynomial, like a cubic. All right. What about the inverse? If I draw a horizontal line here, I can see that it's crossing multiple times. That means this is not a function. The inverse is not a function. So if either of these answers are no, then we would say it's not one-to-one. So what I want to ask you is, let's brainstorm. Which of the parent functions are one-to-one? Now this doesn't mean transformed, just straight up parent functions, which you should have memorized because we just took a quiz over this. Which of the parent functions are one-to-one? Okay, well, we've got y equals x, that line. That's function both ways, vertical and horizontal. The parent function of y equals x cubed is also one-to-one, all right, because it doesn't have this loop-de-loop that this graph has right here. All right, so this is a rough interpretation of x cubed. What about y equals x squared? That would be a parabola. Nope, not one-to-one. Its inverse is not a function, which we saw when we had to do something like this. We saw that you have to kind of tweak it a little bit to make it be a function. All right, what about square root of x? If you start with square root of x, you're good. Just this piece and its true inverse is a function, okay? What about y equals e to the x? Hopefully you're kind of getting the hang of this. Function vertical line test, inverse is also a function. You're good. And its true inverse, y equals natural log of x, that's also 1 to 1. And then there's one more. Y equals 1 over x. It's a weird one, but it's 1 to 1. This idea of 1 to 1 has some significance that you'll see later, but for now, we just need to get the terminology down. Okay, bring your questions to class.